Assalamualaikum and hi, my name is Muhammad FIRDAUS AMEEN. So today we're gonna explain about our lab 5, which is voltage regulators. For the first part, which is part 1, is an op-amp series voltage regulator circuit. So this is the circuit that we need to construct in the multisim. So I will go straight away to the procedure. So the first one, it asks us to calculate voltage across R4 here when the Zener diode, this one, reach the Zener voltage point. The Zener voltage point is the voltage point which the voltage across the Zener diode, this one, becomes stable. So it is called a Zener voltage. And for the Zener diode, this voltage can be in range from less than 1 volt to a few hundred volt. So the number 2 is to construct the circuit in multisim. So this is my circuit construction in the multisim. And number 3 is to set the minimum value for V2, which is our input, to 1 volt, and the maximum value here for 15 volt, which is 1 to 15. So we need to set the increment value 0.5 volts. So number 4 is to increase the voltage V2 by the increment 0.5 and measure the voltage across resistor R4 and tabulate the data. So this is my circuit construction, and this is the data tabulation, like for 1.4, 1.5, which is increment 0.5, and this is the value for voltage at across resistor R4. So this is my simple calculation for the V out based on the formula given in the lab sheet, and this one for the observation, which is, as you can see, the voltage across R4 is increased directly proportional with the value V2 until certain value before it becomes stable. As you can see here, increase directly proportional until like certain point it become a bit stable, but still slightly increase. So I think that's all from me. Thank you.
Assalamualaikum, my name is Muhammad Shafiq bin AKMAL AZIZ. I'm going to show you part 2, which is full bridge voltage regulator circuit. In this circuit, we have to construct a full bridge voltage regulator circuit using diode and LM7805 IC. The first, he want us to construct, and then the second one is to identify the full bridge rectifier circuit. The full bridge rectifier circuit is the diode one. The voltage smoothing filter is C1, and the voltage regulator circuit is LM7805 CT. And then after that, we have to measure the ripple voltage and capture the output for each circuit using oscilloscope and tabulate the data. And then continue to number 3 is replace the smoothing filter capacitor with 220 microfarad. This is the output that we have. This is the circuit, and this is the output. This is the voltage regulator. Voltage regulator, we output going to get 5.001 volt, and this is how the output with the 220 microfarad. In 220 microfarad is more suitable and more the line is more steady than the than using 10 microfarad. After we using 10 microfarad, we get peak to peak value is 4.16, but the grade in this lab, we can see the frequency is getting double the frequency, because the input we have the frequency for input we put it for 30 Hz, but the output we can get 60 Hz. That's all.
So moving on to part 3 for adjustable voltage regulator circuit. So we are going to construct the DC input adjustable voltage regulator circuit using voltage regulator LM7805 by using multisim. So the DC power will serve as the input voltage, and the value of a voltage in R1 will serve as the output voltage. So the usage of capacitor is to help smooth out the power supply in case of abrupt current spikes. So we will start taking measurement once we adjust the value of potentiometer until the value of output VR1 is 5 voltage, and then we measure the resistance value for R3, and then measure the value for the voltage for R3 and R2 respectively, and repeat it for the other desired value for the output VR1. So this is the measurement that we obtain from the entire measurement activities. So judging from this table, the output voltage from this circuit can be set to range from 5 to 7.5 voltage. And this is one of the example of the circuit that we created to obtain the output voltage for the VR1 5.5 voltage, and this one for the 6.5 voltage, and finally for the 7 voltage. And that is all from us, and thank you for watching.